Hey there, how is everything going on? Today I'm going to start another series of video, and in this series you will learn about reinforcement learning, analogy and DQN. Okay, without wasting any time, let's start, move forward rapidly. So this tutorial is less about code and more about to understand how reinforcement learning analogy actually works. So I'm going to start and giving you an overview with uh, with a training session of horse for obstacle race. If let's say imagine a situation that you are training a horse for obstacle race and you are the jockey, and whenever you train the horse, it is open an environment contains some obstacle, and if it successfully pass all the obstacle, then it wins the race. While you are training the horse, whenever he pass successfully obstacle, meanwhile it gets reward and jockey pips him. That means you pet the horse, while in the reverse jockey whip the horse. So if horse continue, passes the obstacle, then it successfully wins the race. So here's the analogy, moves forward. Horse is represented as agent who is exposed to the environment, and the environment is the racetrack. State, follow the jockey instruction. Action, jump and run. And after jump, horse get reward or penalty. The policy is the strategy of choosing an action given a state with an expectation of better outcome. So these are the basic requirements for applying the reinforcement learning. So creating such type of environment is really time consuming. So with the help of OpenAI Gym environment, these all things are available to us. And let me start by the coding part. So in this tutorial, what we are going to do, we are going to teach a taxi to pick up and drop off passenger at the right location. Prior to start the coding part, I want you to understand about little bit about the OpenAI Gym environment. It simply means gyms give you an access of agent which can perform a specific action in an environment. In return, it gets the observation and reward as a consequence of performing particular action in the environment. The core gym interface is being stored in here in a env. You can install gym environment by typing pip install gym atari. Okay, guys. The, and a few things I want you to understand. Env reset as env contains all the core gym interface. So some of the built-in functionality for I want you to tell you that if you just type env reset, then it reset the environment. Every step is associated with an action. There are in this case, this is a grid size of 5 by 5, that means 25 possible locations, and each location is while the driver is reach any location, it can perform a certain action, and there are 6 possible action in the environment. I have listed down at the bottom. South, the driver can go south, driver can go north, driver can go east, west. It can pick some passenger or drop off some passenger. Okay, so if action is beneficial, then it get reward, else it get penalty. The env done indicate if you have successfully picked up or drop off a passenger. Info give you additional information such as performance and latency for debugging purpose. env render is to visualize the environment. You will see everything in this tutorial and you will understand how these things work. So I have imported the gym environment here. Okay, I'm taking taxi environment version 2 in this case, and env render is for visualization. While I run the code, you would be able to see this yellow color is indicate the taxi. R, G, B and Y, these are the 4 passenger locations. Okay, and the grid size is 5 by 5. So in that case, the total number of state corresponding to this environment is 500. Let me explain how it becomes 500. The 5 by 5 grid represents 5 multiplied by 5 is equal to 24. There are 4 possible locations multiplied by 4. 25 multiplied by 4, that is stand for 100, and 4 passenger and and 1 passenger can be inside the car, that means 5. 100 multiplied by 5, that represents 500 total state. And the action, as I have already told you, there are 6 possible action. Driver can move south, driver can move north, driver can move east, west, can pick the passenger or can drop off the passenger. So that's why total number of states are 500 and possible action can be 6. So let me run this part. I've explained you these things. Yeah, you can encode the driver state, and while you encoding the driver state, the built-in encode function is enable. You can get particular state that first thing is represented the taxi, the second is number of taxi row, second is taxi column, third is passenger index and destination index. So if I go for some other encode, like number of passenger row can be 4, column can be 3, passenger index can be 1, then I'll get different state 464, and here's the driver. So let's move further. I'll show you each state where the driver is, all 500 transition state and the location of driver. I write it down here. You can visualize that like this. Then I have already told you the action space, south, north, east, west, peak, drop. There is a reward table, and you can visualize the reward table by E and B. So after getting a closer look about the action space, let's move further for reward table. So let's see how the reward table look like. So the reward table contain all possible action, that means 6 action for a particular state, and if on any state, if driver will take certain action, what will be the next state, what is the probability of taking certain action, what will be the reward, and whether it reach to the destination or not. So as you can see, negative -10 is the penalty, -1 can be the future reward. So each action is while driver taking any action, it will get whether reward or penalty in as a consequences. I'm going to train my agent and try to make automation without reinforcement learning, and let's see what happens if we will try to build a random theory. We will randomly train our agent and then see the outcome. So here I can set any state. So I start with state number 5. The number of epoch, I'm not training any agent. Penalty and reward at the very beginning are 0. The frame for the purpose of animation, that so that while agent get trained, agent will reach the destinations, what are the actions it will take and how many times it faces the penalty. If it get -10 rewards, that represent the penalty and it get append each time. Total number of penalties will be 71, and the time step it takes is 195 to reach the destination. Let's say while I start from another state, it takes 147 time steps and penalty in occur 42. Let's visualize how it reaches to the destination and what problem it faces and how many times it faces the penalty. So it takes 147 steps, and so finally it drop off or pick off the passenger at the end. So let's enter reinforcement learning environment. Let me give you an overview how the reinforcement learning environment look like and what are the basic parameters. I'm going to introduce you in this lecture the introduction of Q learning, and we will perform some other action in this tutorial, and let's see how each action and each value is valuable for us. The most important thing in Q learning is the state table and the Q value.